Hey, my dear students, hello again. And I've got another pre-university course problem related to chemistry. And it's offered by an Uzbek girl by name Jasmine, if I remember rightly, Jasmine. Well, and I just wanted uh, to have a look at this problem. Well, it's an interesting assignment, actually. So here is the assignment to the problem. So some substance X reacts with aqueous solution of hydrochloric acid, just like manganese oxide does. So that means that we've got two reactions. The two substances taken in the molar ratio as 1 to 2, with a total mass of 41.3 grams, yields 6.72 liters. And we've got the thermodynamic conditions, 1 atmosphere and 273 Kelvin grades, okay, of chlorine gas. Compute the X substance mass. Okay, so what should we do? First of all, let's write the schemes of the two reactions, taking in consideration the fact that towards the aqueous solution of the acid, they react similarly, which means that water molecular chlorine and the two chlorides are formed. So the first reaction, so that'll be XO2. Actually, this is the substance X. In these conditions, they are equal, similar, not similar, but identical. XO2 and that X, okay? So XO2 plus 4 moles of HCl. So XCl2 plus Cl2 plus 2 moles of water. And the other reaction is manganese oxide, MnO2 plus 4HCl. And we've got manganese chloride plus Cl2 and plus 2 moles of water. So we can write these schemes of the reactions because like this, because the problem says that this reaction reacts with the aqueous acid solution the same as manganese oxide does. That's why these two are nearly identical. The only difference is in the composition of chlorides. Okay, now from the problem situation, we know that the amount of XO2 corresponds to that of, right like this, corresponds to that of manganese oxide as 1 to 2, right? Okay, so let nu of XO2 equals X moles, okay? And from this relation, we can write that the amount of manganese oxide equals 2x moles. I guess it's clear from this relation. Okay, from the reaction schemes, we can see that the amount of chlorine gas yielded in the first reaction is the same as that of XO2. Why? Because the coefficients are the same, 1 and 1. For that reason, I can write down that the amount of chlorine gas from the first reaction is equal to the amount of XO2, and correspondingly it equals to, I'm sorry, X moles, right? Okay. Now, if we follow the same logic and take a look at the second reaction, we will see that the coefficients before manganese oxide and molecular chlorine are the same. For that reason, we can write down that the amount of chlorine in the second reaction is the same as that of manganese oxide, and that means twice X moles, right? Okay, okay. Now, the total amount of chlorine yielded in the result of the two reactions is the sum of this and this, right? That means X plus 2X, 2 times X, and we've got 3 times X moles, right? Okay, that means 3X moles of chlorine. Okay. Then let's remember that under the conditions given in the problem, 1 mole of an ideal gas occupies roughly 22.4 liters. We know that. And that means that we have got a simple algebraic equation. We know that the molar volume of an ideal gas occupies roughly 22.4 liters, right? Okay, and we've got 3x moles. That means that if we multiply the molar volume to the total amount of the moles of the gas, we will get the volume of the gas. So we've got the equation 22.4 times 3x, and that makes 6.72 liters, right? The root of the problem, x equals 6.72 into 22.4 into 3, and that gives us the value of x, which is 0.1 moles. Now we know that the amount of the XO2 is 0.1 moles, right? And the amount of manganese oxide is twice that number. So that means 0.2 moles, right? Okay. And now we can calculate the mass of this substance. If we multiply the number of the moles to the molecular weight of the substance, we will get the mass of manganese oxide. So that means 55 plus 32 times O2, and we will get 17.4 grams, okay? So now we've got the last step in order to obtain the result we asked for. So we know that the mass of the mixture is 41.3 grams, right? That means that the mass of XO2, okay, or is like it X, okay, doesn't matter, is we should subtract the mass of the manganese oxide from the mixture. Yeah, I guess it's quite obvious. So 41.3 minus 17.4, and we finally got 23.9 grams. So that's the answer. Okay, this is the answer to the problem. Thank you very much for your attention. So if you've got any problems, any questions, feel free to ask me. Bye.